Hello students, as in the last lecture we had completed the type number 6. As I told, the type number 4, 5 and 6 are the important type from the chapter, and even we completed the type number 1a, which was in the form of 1 upon quadratic. Type number 1b also linear upon quadratic. Type number 2a also, that is integral 1 upon root quadratic. Type number 2b also linear upon root quadratic. And today we're gonna see the type number 3a, which is in the form of integral root quadratic. As I told in the last lecture, we'll see the type number 3 after all the three types, that is after type number 4, 5 and 6. So today we're gonna see the type number 3a, which is in the form of integral root quadratic. As we know that for integral 1 upon quadratic there are three formulas. Integral 1 upon root quadratic, again there are three formulas, and even for integral root quadratic there are three formulas. And even I told how to remember the type number 1a, 2a and 3a. It is very simple. Type number 1a as 1 upon quadratic, type number 2a as 1 upon root quadratic, and type number 3 as only root quadratic. And even the formulas also, it is similar. Here it is 1 upon x square plus a square, 1 upon x square minus a square, and 1 upon a square minus x square. Here also it is 1 upon root x square plus a square, 1 upon root x square minus a square, 1 upon root a square minus x square. Like clearly you can see that x square plus a square, x square plus a square, x square plus a square, it is there. Then x square minus a square, x square minus a square, x square minus a square, a square minus x square, a square minus x square, and a square minus x square. For all the three types there are three formulas. Okay, just the change is what? The right hand side section, that's the answer. So now we'll see how to remember type number 3a formulas. Okay, as the first one is what? Integral root x square minus a square. As the formula, it is little lengthy and it look like it is difficult to by heart the formula, but there is a simple trick to remember the formulas of type number 3a. It is very simple actually. See here, now I will explain how to remember this. Square root x square plus a square into dx is equals to, first you will write x by 2, then root x square plus a square, then plus a square upon 2, then log mod x plus root x square plus a square plus c. Now listen here. For type number 3a, simply you have to remember the formulas of type number 2a, because here when you will see, when you will compare the type number 2a and type number 3a, just now I will explain here in the tricky way how to remember the formula. First you will write x by 2, yes or no? First you will write x by 2. Then can you say root x square plus a square is what? The question only, yes or no? Then you will write the question. Then after that you will write plus, then a square upon 2. Okay. Then after that, can you see this log mod x plus root x square plus a square is what? Log mod x square plus root x square plus a square is what? It is the type number 2a formula only. Okay. So here I will write type number 2a formula, yes or no, and then plus c. So you can remember this formula as like this also. X upon 2 question plus a square upon 2, then this section exactly it look like what? type number 2a formula, yes or no? So as 1 upon root quadratic root a x square plus a square, the formula is log mod x plus root x square plus a square. So here also it is root x square plus a square. So root x square plus a square, the formula it is this section, actually it is similar. Okay, so in this way you can remember x by 2 question plus a square upon 2, then type number 2a formula. Okay, then for the second one, root x square minus a square into dx, the formula is x by 2. So first you will write x by 2, then this x square minus a square is what, this question only, yes or no? Then question, then after that you will write minus, as here we have like minus, you can remember like this. Okay, minus, then after that you will write a square upon 2. Okay, then this section is what look like the type number 2a formula only. Okay, so here I will write again type number 2a formula, yes or no? So to remember the type number 3 formula, you must know the type number 2a formulas. Okay, so then only it will be easy to remember the formulas of type number 3a. Okay, now we'll see the next one. Root a square minus x square into dx is what, x by 2, you will write x by 2. Then this part is the question only, yes or no? Then plus, then you will write a square upon 2. And this section is what, again it is a type number 2a formula, yes or no? It look like type number 2a. So this all section, this section, this part and this section is the type number 2a formula. So that's why I told before learning the formula of type number 3, just try to buy the formulas of type number 2a. So it will be easy for you all to frame the type number 3a formulas. Okay, so once again we'll see here. So what is the trick here? In all the three cases, clearly we can see that x by 2, x by 2, x by 2 it is there. Okay, then after that you can write question, the same question and then same question. Then here it is plus, minus, plus, yes or no? Then after that it is a square upon 2, a square upon 2, a square upon 2 common. Then here the formula is what? Type number 2a formula, type number 2a formula, and type number 2a formula, and then plus, plus c you can write. Okay, so in this way you can remember your type number 3a formula. Okay, and actually these three are the very important theorem also. Please note that these three are very important theorem in the integration chapter. It may or may not come in the board exam, but in this chapter there are some theorems also, and even in the derivative chapter also there are some theorems. So these are the three selected very important theorem from the chapter. So please go through the theorem part. Okay, but in this lecture I will gonna explain only the concept and how to buy the formula in a tricky way. But the theorem part, it is there in the textbook. Just go and refer the theorem. The three theorems are very important theorem, and it each and every theorem carries off 3 to 4 marks. Okay, so let's begin with the sum now. Let's take the first example. As the first example is what, I equals to integral root x square plus 2x plus 5 into dx. So let's begin. As clearly we can see that it look like integral root quadratic, and we know that whenever it is a integral root quadratic, for root quadratic, that is a proper quadratic, yes or no? It is in the form of integral root ax square plus bx plus c into dx. As per the rule, we know that first we have to make the coefficient of x squared term 1 and the symbol should be positive, yes or no? Okay, so first we'll make the coefficient of x square 1 and the symbol should be positive. If the symbol is negative, and we know that whenever the symbol is negative for x squared term, always and always you have to apply the formula number 3. First and second, when to apply? When we have to apply? Whenever in the question itself it says that the symbol for x square is positive. As here clearly we can see that already in the question it says that the symbol for x square is already positive, then there is no doubt either the first formula will come or the second formula. Okay, so let's begin with the first sum. As clearly we can see that the coefficient of x square term is 1 and the symbol is positive, so after that we have to apply the third term. So we know that third term will be what, half into coefficient of x is here what, 2 the whole square. So your 2 will get cancelled, so 1 square is what, 1. Yes or no? So therefore the next step we can write as what, I equals to integral root x square plus 2x. What to do about this number? We have to add the number to the alphabet and subtract that number to the number, yes or no, then into dx. So therefore next part will be what, I equals to integral root, this we know that we can write as what, x plus 1 the whole square, as this section look like what, a square plus 2ab plus b square, which we can write as what, a plus b the whole square. You can expand and you can see you will get the previous step only. When you will expand x plus 1 the whole square, you will get x square plus 2x plus 1 only, yes or no? Then 5 minus 1 is what, 4. Okay, then after that the next step, this will keep as it is, and this 4 can be write as to the whole square, as we know that we have to convert both the section into whole square because we have to compare the formula, yes or no? I hope you all understood the three steps. Okay, now we have to compare the step with the formula and we have to apply the suitable formula. As the first section is x plus 1, this 1 is with variable, so we'll consider the whole section this x plus 1 as the variable, and 2 is a number, and here the connection is plus, as clearly we can see that this section look like the formula number 1. The first section is the variable and the second section is the number and the connection is plus, so we have to apply the first formula. It says that x upon 2 root x square plus a square upon 2 log mod x plus x root x square plus a square plus c, and I had explained how to remember the formulas also. Okay, so let's integrate with respect to x. So here the final answer, whatever the answer you will get, now we'll see x plus 2. So this part is x and this is what, a. So x plus 2, so x, sorry, x upon 2, so here it is x upon 2. Okay, so this part is x and this is the number, so x plus 1 upon 2, because this is x. This is what, the same question, no? Yes or no? So we'll write the same question now, that is x plus 1 the whole square plus 2 square, yes or no? Then after that it is what, plus, then a square upon 2, here a is what, 2, so we'll write 2 square upon 2. Then this section is what, the type number 2a formula, so log mod x, what is there in place of x, that is x plus 1 plus root x square plus a square, that means the same section, so this same part will come, yes or no, plus c. So we have to integrate the this step with respect to x. So now we'll do the adjustment, a basic adjustment. Okay, so when you will solve this section, x plus 1 the whole square plus 2 square, so here it will be x square plus 2x plus 1, and this 2 square will be what, 4, plus 2 square, here it is what, 4 upon 2 log mod x plus 1 will be same. Again when you will solve this part, this will be x square plus 2x plus 1 and this 2 square will be 4. Okay, you have to expand this section and then you have to write the final step. Okay, so x plus 1 upon 2, so this part will be x square plus 2x plus 5 plus, so this is 2 ones are 2 twos are, so this will be 2 into log mod x plus 1 plus root x square plus 2x plus 5 plus mod c. So that's the end of the sum. So in this way you have to frame your sum for the type number 3a, which is in the form of integral root quadratic. Yes or no? Your type number 1a, it was 1 upon quadratic. Type number 2, it was root 1 upon integral 1 upon root quadratic. And type number 3, it is only integral root quadratic. And for this also there are three formulas. As I told, before remembering the formulas of type number 3a, first you buy it the formula of type number 2a, so it will be easy for you all to remember the formulas of type number 3a. As this section, this part is look like similar as the formulas of type number 2a. Yes or no? So in this way you have to present your sum. So let's take some few example based on the same content, the same type, that is type number 3a. So let's take one more example. As here the second one is what? Integral root 2x square plus 3x plus 4. As here clearly we can see that the coefficient of square term, it is not 1. So first we have to make the coefficient of the square term 1. So let's see how to make the coefficient square term 1. It is very simple, just remove this 2 as common. So here you will get what? X square plus 3 by 2x plus 4 upon 2 into dx. Yes or no? So I equals to, this we will write same as it is, 2 x square plus 3 upon 2. Yes or no? 3 upon 2 x plus, so this we can write as 2 ones are 2 twos are into dx. Yes or no? Suppose we'll consider this section as one part and this section as second part. So can I write this section as root 2 into root x square plus 3 upon 2x plus 2 into dx, as this look like what? Root a into b. So this root a into b we can write as root a into root b. As here clearly we can see that the orders are same. When the orders are same, we can multiply and we can separate this two part. Yes or no? So that only I did here. So we'll consider this part as a and this section as b. So that is root a into root b, we can write as root a into root b. Understood? So here root 2 is what? It's a number, it is a constant over there, we can say. So root 2 we can bring outside the integral. So this part will be what? X square plus 3 upon 2x plus 2 into dx. I hope you all understood till here how to make the coefficient of x square term 1. If you don't know, you can go and watch the previous video, the sums based on the type number 2a. There I had explained how to make the coefficient of x square 1 whenever it is inside the quadratic is inside the root. So whenever it is inside the root, so this is the method in which you can make your coefficient of x square 1. First bring the common outside the bracket and you will write that number inside the root only. Okay, see to it that you write the number inside the root only. Okay, then after that this section look like root a into root b, which we can write as root a into root b separately. Okay, because the orders are same, so when the orders are same we can multiply. Okay, so after that root 2 is the number, so we can bring the constant outside the integral, and the rest we all know that how to present our sum. So after this, clearly we can see that here the symbol of x square is plus and the coefficient 1. We can apply the third term concept. So third term concept is what? Half into coefficient of x. Coefficient of x here, it is what? X by 2. Yes or no? So here 3 one side is 3. 3 square is 9. 2 twos are 4. 4 square is 16. So now we'll add this 9 upon 16. Add this 9 upon 16 to the alphabet as per the rule, yes or no, and we'll subtract 9 upon 16 to the number, yes or no. So after this, we'll keep this root 2 as it is. Integral, here both are positive, so this will be in the form of a plus b the whole square. So we'll write x plus 9 square root is 3 and 16 is 4. So with this we can write as x plus 3 upon 4 the whole square, plus this we can write as 16 to the, it is 32 minus 9 upon 16. So 32 minus 9, here it is plus 32 minus 9 is 23 upon 16. So this we can write as 23 upon 16 into dx. I hope you all understood till here. Okay, so now this root 2 will be same as it is square root. So this will be x plus 3 by 4 the whole square. 23 by 16 we can write as root 23 upon 16, square root is 4 the whole square into dx. Okay, so now we'll try to compare this step with the formula. As this 3 upon 4 it is with x, so we'll consider this part as variable and this part as number, and here the connection is plus. So clearly we can see that it look like formula number 1, and it says that x by 2. So we'll see what is x by 2. We'll keep this root 2 as it is. Okay, so x by 2, x is what here? X plus 3 upon 4 x by 2, yes or no? Then the same question will come, so this same part will come, yes or no? This will be x plus 3 by 4 the whole square plus root 23 upon 4 the whole square. Okay, then after that you will write what? Plus then a square upon 2. So here a square is what? Root 23 upon 4 the whole square upon 2 log mod x. So x is what here? X plus 3 by 4 plus root the same section, so this part will come x plus 3 by 4 the whole square plus root 23 upon 4 the whole square, mod closed and plus c. Okay, then we'll do the basic adjustment here. So we'll write this root 2 as it is. So when you will cross this part, so here you will get 4x plus 3 upon 4 will go down, so this will be 8. Here nothing is there, so we can write 1, yes or no? So 4x plus 3, and here it will be 4, and this 4 will go down, so 4 to side is 8. And this part, when you will solve x plus 3 upon 4, when you will solve this, when you will expand this part, when you will expand this part, so you will get the previous step only, this section only you will get, yes or no? So directly I will write the answer here. So here you will get x square plus 3 upon 2 x plus 2 plus root 23 square, it will be what? 23. 4 square, it is 16, yes or no? 4 square, it is 16, and 16 will go down, so it will multiply with 2, so this will be 32 log. Okay, so when you will solve this part, so this will be 4x plus 3 by 4, and this section will be same as it is, you will get the same answer, yes or no? Because this part and this part it is same, so when you will expand and solve this section you will get the same answer, yes or no? So you will write x square plus 3 upon 2x plus 2. This part you can write directly. If you want to show the expanded part you can, otherwise you can write the answer directly, as we know that you will get the same step. Okay, and then plus c. So that's the end of the sum. So in this way you can present your sum in the board exam. I hope you all understood the both the example number 1 as well as 2. In the example number 1 we took the sum where we saw the coefficient of x square, it was 1, already it was 1 and the symbol was positive. And in the second example we took one example where the coefficient of x square it was not 1. So in both the cases we got the idea how to present our sum. So let's move on to the next sum, that is question number 3. Okay, so now here we'll take one more sum, as this is also, it is in the form of root quadratic, integral root quadratic. But here the format is what? The first and the last term and the middle term is absent, and we know that whenever the middle term is absent in the quadratic form, okay, so no need of applying the third term concept. So directly here we'll apply the formula. Before that, first see, the coefficient of x square term should be 1 and the symbol should be positive, as the symbol is positive but the coefficient it is not 1. So here again same, we'll do what, we'll bring phi outside the integral, but that phi it is inside the root, so whenever it will come outside, it will come outside with the root phi. Okay, so I will explain the sum by this method only. Okay, so first bring common, as here phi will take as common, so inside the bracket you will get x square upon 3 upon 5, yes or no? So the next step, this part will consider as a and this part as b, like here we did. Okay, so this section we can write as what, root 5 into root x square plus 3 upon 5 into dx. Further, root 5 is constant, so we can bring in outside the integral, so root 5, this we can write as x square upon x square plus 3 upon 5 into dx. Okay, and the next step we can write as what, root 5 same as it is, and this we can write as x the whole square plus, we don't have the square root of both 3 and 5, so we'll write as root 3 upon root 5 the whole square into dx. So now we'll compare the formula. So this section look like what, the formula number 1, as the connection is plus, this is number that is a and this is the variable that is x, so this look like the first formula only. Okay, and the rest part I hope you can solve by yourself. Just simply apply the formula, substitute the value of x and a, and do the basic adjustment and you will get the final step. Okay, I hope you all understood the third sum also. So now we'll take one more example where we'll see if what, the symbol of x square term is negative. Okay, so now we'll see the next sum, as here we have the pattern, it is a little different. Here we have two section inside the integral, that is x minus 3 and 7 minus x. So let's expand this bracket. So here when you will expand, so this part will be 7x minus x square minus 21 minus minus plus 3x into dx. I integral, so this part first will write x square term, then after that x part, so 7 and 3 it will be 10x, and the number, so minus 21 into dx. So now it is in the proper quadratic form. As per the rule we know that first whenever the symbol for x square it is negative, first we have to make the symbol positive. And as I told in many videos that whenever the symbol of x square already in the integral section, if it is negative, see to that you have to apply the third formula, that is root a square minus x square part. Okay, so first we'll make the symbol positive. So we know that how to make the symbol positive. It is very simple. Just bring minus outside the integral. Sorry, that means outside the box bring bring minus as a common. So here we'll write x square minus 10x plus 21. Okay, this is the integral section. Yes or no? I equals to integral root. Okay, keep this minus inside the root only, and that is inside the integral. If you want to bring outside, you can, but I will suggest to keep this minus as it is. Okay, inside the root only. As this is the proper quadratic, middle term is present, so we can apply the third term concept. So half into coefficient of x the whole square. So here 2 ones are 2 5s are minus 5, you will get 25. Yes or no? So we know that what exactly we have to do afterward. We'll add the number to the variable section and we'll subtract the number to the number. So therefore I equals to integral root minus, yes or no? So this part we can write as what? X minus 5 the whole square, and 21 minus 25 is minus 4. Yes or no? So integral, if you want directly, you can write as minus 4 here itself. Okay, so minus, as when you will expand this part, this section, this part, it is in the form of a square minus 2ab plus b square, which we can write as a minus b the whole square. Exponency, you will get the same step. Okay, I hope you all might be knowing how to present the sum whenever it is in the form of root quadratic. Okay, first we have to make the symbol positive, the coefficient should be 1, and apply the third term. Okay, I hope you all might be knowing this step, because in many types we had did this. Okay, so x minus 5 the whole square and plus, here itself in this step only directly you can write as minus 4. Okay, so plus minus, it is minus, and 4 we can write as 2 the whole square into dx. Okay, now we can bring this minus inside. So here this minus minus will be plus. So first we'll write 2 square, and this part will be x minus 5 the whole square into dx. Yes or no? So now we can say that the first one is the number, and x minus 5, this 5 is with the variable, and here the connection is minus. So the first one is a and the second one is x. So this look like a square minus x square. So a square minus x square means we have to apply the third formula, that is x upon 2 root a square minus x square plus a square upon 2 sine inverse x upon a plus c. And I hope you can solve the remaining section by yourself. Okay, so that's the end of the type number 3a, we can say. I hope you all understood the type number 3a. Okay, so till now we had completed the type number 1ab, type number 2ab, type number 3a, type number 4, type number 5, and type number 6. Okay, so in the next lecture we're gonna do the next type. Okay, till then, goodbye, see you in next lecture. I hope you all understood all the 4 example which we took today based on the type number 3a. Okay, just try to buy the formula in this tricky way, or else it is on you how to remember the formula. It is on you. Okay, so till then, goodbye, see you in next lecture.